Hello folks. Okay, this time I want to talk about code reuse in general, and then we'll get into maybe some more specifics dealing with C++ and some template libraries in the next session. So, the basic idea is that as much as possible, we'd like to reuse existing code, right? It makes things faster. You don't want to rewrite everything from scratch every time. So, a couple of issues that we have to consider is that the code you want to reuse needs to be flexible enough so that you can reuse it effectively, right? If you wrote a routine to get a number, but you made it very specific to the whatever you were using it for when you wrote it, then you probably can't reuse it easily for something else. So you need to write your code in a flexible enough manner to make it easy to reuse, to make it easy to use in different situations. Then when you want to reuse code, you have to be able to find it. So you have to be able to find the suitable batch of code, whether it's a class or a function or a method or whatever it might be. You need to find the item that you want to reuse. And that might be code that you wrote or something that somebody else wrote, something that somebody else maintains. So we need a mechanism for looking up, finding the things that might be helpful. We also need to be able to trust the code that we want to reuse. So it's got to be a high enough quality that we can actually trust it. And somewhere along the lines, we have to figure out who's maintaining this, right? We need to maintain our own code and reusable code and make sure that that's done in a manner that's going to be compatible for all of the different places that it's being used. So there are a few issues to consider in general. All right, some of the things to worry about are when is it actually worthwhile to use reuse, to go through this process of finding something that we can reuse as opposed to writing something from scratch. Right? Quite often the code that we want to reuse, if you like, doesn't do quite exactly what we want. Either it doesn't do enough or it does some extra stuff that we don't really need. So quite often when we go to reuse the code, we need to either customize it a little bit or wrap it in something else, have some other chunk of code that calls it, extracts the part that's useful, and kind of ignores the rest. So we might need to do a few extra steps to reuse a chunk of code. And so you're trying to balance the time saving that you're getting from using pre-existing code against the cost of the time that you spend in customizing it or wrapping it, and the time you spend searching for it, and any extra maintenance overhead and whatnot that might be included, any extra testing that you might have to do because you're not really sure if you can trust the code that you're reusing. Right? So all of that stuff has to be factored into your decision as to whether you're going to write something or whether you're going to reuse something. And again, a big part of that is how much can you trust the original source, right? Who wrote it? Who's maintaining it? Is it somebody that you've worked with a lot in the past and they've traditionally got high quality code? Is it from a trusted source, and just exactly what is the story, right? And that's part of the, if you like, risk assessment when you're deciding whether or not to use code from elsewhere. Now, in terms of finding the actual code, well, obviously there's a lot of built-in libraries provided with languages. There are a lot of common and trusted extensions and libraries available for different languages and different purposes. Those we can usually trust, and those are usually going to be written fairly in a fairly flexible and extensible manner. We might have a bunch of in-house code, right, our own code or our own team's code that we trust, that we've used before, that we have some faith in, and that we can actually find the author if we need to go through and tweak things if necessary. Right, so those are the most common sources for things that we want to reuse. But you might find more extensive choices. You might find some place where you can search for code that does something that you want. But of course that brings in the question of how much you can trust it. Now, actually going through and doing the search to find something suitable can be pretty challenging. Suppose you work for a big organization with lots of teams and it's built up this huge library of different chunks of code that's available. Finding in that something that does just what you're looking for can be pretty challenging. right? It means that you need decent documentation or a decent catalog or a decent search tool to look through what's out there and get good information on its features, its functionality, its reliability, that kind of idea. And of course, there's the issue in terms of who's got the rights to the code that you're using. You do want to make sure that you do actually have the right to do the things you're doing with it before you go ahead and start using them. Now, in terms of writing your own code with the idea of reuse in mind, of course you want to make sure that the code is stable, it's robust, it's well commented, it's high quality, it's well laid out, you've tested it thoroughly, and you want it to be reasonably generic. So if you're writing a function to get an integer in the range m to n, then you don't want to write it with prompts that are specific to one particular purpose. You want reasonably generic prompts, or better yet, you want the prompts and error messages and things to be configurable, where maybe somebody can provide them as parameters to the function, where it will say, display your prompt, get the values, do the error checking, display the error message you want if something's out of bounds. Right? That kind of idea can make a function much more reusable. Right? The bulk of it isn't changing. All it's changing is the specific values for m and n and the specific prompts to give the user eventually and in the event of an error. When you're working with abstract data types, again, you want to make them work off flexible data types. Instead of having a stack of ints and a stack of floats and a stack of strings and a stack of whatever else is, right, you want to essentially have a template for an abstract data type that says, here's the stack, and we can plug in a data type here. And that's what we'll get into in our next session, talking about templated types. And of course, you want decent documentation in a suitable place so that you can actually find it, so that you can find the chunk of code that you just wrote, right, using keywords and things that will make it obvious for somebody who's searching for this. So again, code libraries are a huge thing. You want to make use of existing code libraries where possible, right? Know the common libraries for your language, know how to search them, know the kind of common collections. If you're using C++, be familiar with the standard C libraries, the C++ standard template libraries, which we'll get into very shortly, right? The STL. Find good reference sources. Again, for C++, it's things like cppreference.com or c++.com, right? This kind of idea where you can find libraries and information on them so that you aren't writing things from scratch and so that you are using code that's been reasonably well tested. All right, that's where I might leave the general section on code reuse, and we'll get into the idea of templates and template libraries in our next session.